time left at the end of class today, we will use it to play the game. Okay? So, we've talked a lot about Cecil, right? So in your book, we are in 224. So please go ahead and find that page with me in your textbook. It is 98. Page 98 in your student text. Sometimes when Cecil does routines, he uses the same move in a repeated fashion. So, because I don't have much space to work with, let's say that these values are inches. So, Cecil, say I'm Cecil, moves 7 inches, 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 7 inches. I kind of lost count. And then 5 back, 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 5 back. How could we say that potentially easier? Because that's kind of annoying. I will tell you that was annoying to say. Alex?
7 times 8.
1, 2, 3, 4, 5, 6, 7, 8. I love it. I'm actually going to switch the order around. We could say 8 moves of length 7, and then and then 8 moves of 5. Now wait, if I do, anybody? There's a mistake up here. Delaney? The 5 needs to have the negative. Always be careful with that. I will do that intentionally sometimes to see who's paying attention. I need to go to Sam's Club. I'm sorry. Once I actually have candy, those sort of things will be worth candy. If you catch it before I announce it, it's worth candy. So I will do that intentionally sometimes, especially with negatives. So keep your brain turned on.
Wait a minute, you still owe me.
You're right. I still need to go to Sam's Club. Or it comes. I saw Art Taffy if you want that. If we do 8 of each of these, couldn't I just say 8 moves of 7 positive and 5 negative, and just kind of put it together? If we do 8 of each, I'm trying to. Again, my goal is to make your life easy. I want you to write the least amount possible, which Mr. Goldring probably disagrees with. I want you to write the least amount possible. That's how mathematicians work. We want to be efficient. So this tells me 8 moves, and this tells me the distances that I travel. So I want you guys as groups to keep that in mind as we start to work through 67, 68, and move through this lesson. Cool? So, dive into 67, and we will bring you back in a few minutes to discuss it together. As your groups dive into 67, I will capture this. Make sure you date your notes. Is there what? Like one to borrow for class, or one to keep?
Using only the lengths of 5 and 8 at least 2 ways, Cecil can move to just the end of the row at flat. For each solution, draw a diagram.
Thanks. That was a gift from the student. If you just want to borrow it for class, this is a really nice one. Bring me that back, okay? Make sure that as you start your notes for today, you give yourself a new date of 9/29. Today's lesson number is 224. And our title of it is Multiplication is Repeated Addition. So I'm going to shorthand it and say multiplication equals repeated addition. So if you would like to head your notes, hint, hint, nudge, nudge, you should. Wow, Grant's really trying to break the binding. If you want to head your notes, it's multiplication is repeated addition. Mathematically, I can write that really easy. Question. So don't we do that? Remember, a single tick mark above the number means feet. A double tick mark means inches. I know it's art. Flick is a great story. I could spend too much money there. What's up? Ooh, so you know that. Now, if I try to actually make this look like 6 feet, right? So 6 feet. We can do moves of 5 and 8. So once we figure that out, I might go beyond. But if I do a move of 5, and then another move of 5, and then a move back of 8, like I can show it just with different, or you can change colors or work up, work down, whatever you want to do. Remember, if you have opposite numbers involved in your expression, they're essentially pointless. They cancel each other out. So, it's fine, because I heard somebody say 8 plus negative 8. Well, okay, you're making Cecil move, but you really didn't do anything. Let's say 2 minutes. We'll bring this back together then. Remember, I gave you that multiplication table to make your life easier. So if you ever need to reference that, pull it out. And if you don't have one, I can print you another one. Actually, you can print all the resource pages too. I can show you guys how to do that next week. About 30 seconds. Pull it back together. I already forgot that I owned and something less. Why do you have all that money? All right, let's chat together. Aubrey, your card is what? You can't be that surprised. So, these are people that I called yesterday, actually. Yes. Called you. I remember. Yeah, all those people that I called yesterday. All right. So, let's go here. Delaney. Same group, but Delaney has your group figured out a way for Cecil to get from his start to his end.
Yeah.
How did you do it?
I did 5 times 8, 40.
5 times 8. So did you do 8 moves of 5 or 5 moves of 8?
5 moves.
All right, so we'll say 5 moves of a distance of 8, and below that I'm going to notate, I know that's 40. Okay.
And then I did minus 8 times 2.
You can't do moves of 2, so we're going to have to write it 2 moves of a distance of 8. And what's that?
24.
Well, yeah, so minus 16, so that together would have made us 24.
And
Okay.
then I did minus 6 moves.
And actually, I'm going to go ahead and make this plus a negative move, because technically that's what we're doing. So plus how many?
I did minus 16.
I can't hear you. Minus what?
Minus 6 times.
We can't do moves of 3. And we can't do moves of 6. So we need to get to 6, which is going to require, from 24, requires another move of 18 to get to 6. I feel like this is getting somewhat complicated here. Let's start again. Let's go. I don't like this. We just talk. Nathan, do you guys have an idea?
Yeah. 8 plus 8.
So, if it's 8 plus 8, I'm going to go ahead and just say 2 moves of 8. Okay, that takes me 16.
And then 16 minus 5.
So, plus a shift of 5 backwards. Because remember, every time we move, we're really adding to the routine. So, you can write it as minus, but we're really adding negatives. All right, continue.
And that equals 15.
This equals
No,
15?
that equals 11.
Ooh, this would equal 11.
And then minus 5.
Ooh, so if you're going to add another move of 5 the negative direction, could I write that more easily? Could I write this more easily? Yeah, negative 5 times 2, right? Because if I do the same thing multiple times, I can say I really did 2 moves of 5 in the negative direction, and now that will subtract, instead of just subtracting 5, that made 16, and what did this get us? Negative 10, and that gets us to 6. So I can't really draw because I don't have enough screen since I made my tightrope 8 to scale, but we'd go 6, 7, 8, 1, 2, 3, 4, 5, 6 off the screen, then back gets us to 11, and then back 5 more gets us where we need to be. So I'm out of screen, so use your imagination. Patrick?
We got 1.
How'd you do it?
We did 8 times 5.
8 times 5. Starting with 40 again. All right, let me move some of this stuff. Um, 8 times 5, eh? So 8 moves of 5.
Plus negative 8.
Plus a move 8 back.
Plus negative 8.
Okay.
Plus negative 8.
This is getting redundant. How many times do you do that?
3 times.
So I'm not going to write them all out. Instead, I'm going to write they did this 3 times because I hate redundancy.
And plus negative 5 2 times.
So this together, 2 times negative 5 is what? Negative 10. This together Negative 24. What's my total negative? 34. What's my total positive? 40. What's the difference? 6. So that way will work as well. Annika, I'm not going to write it out, but did you have a different one? Are you sure that works? Oh yeah, because then you went negative 10. So essentially, Annika did a bunch of stuff, but ended up 10 backwards, and then came 16 forwards. Really what you did when we make your zeros, right? So I love it. That's the easiest way. Anybody know the easiest? Mm-hmm. So you just said I'm going to do 2 moves of 8, and I'm also going to do 2 moves of negative 5. We could write this 2 moves of an 8 and a negative 5, right? So what if I go 8 forwards, 5 backwards, 8 forwards, 5 backwards, right? So I put the moves together. What's my net move if I go 8 forwards and 5 backwards? Or if I give you $8 and then I take away 5? 3. What's 2 times 3? 6. Here's the easiest way. So moving on to 68. Cecil's got a tightrope spanning from A to B. He takes these moves. How can we help him represent this more easily? I'll give you like 30 seconds. Then show 2 other ways, so not just one other way, 2 other ways. Not just one, 2 other ways we show this. So we obviously see what it's written is 6 plus 6 plus 6 plus 6. Kate, give me one other way we could rewrite this.
12.
Ooh, okay. We might do more than 2 then. Allie, give me 2, or another way. I heard you guys say it. How many moves do we take? This one, that one, that one, that one. How many? You guys can help, right? You guys are a team, yeah. Right, so we do 4 moves of 6. Matt, do you have another one? Ooh, 6, a move of 6, 4 times, which you could write with a dot, we could write with parentheses. Don't use the X. You don't use the X anymore. Annika? Ooh, 6 times 3 plus 6. So there's a bunch of ways we can write this, right? Patrick, give me one last one.
3 8 times.
Yeah, I could break these moves in half and do moves of 3 8 times. So we could actually probably rewrite this all day long. So for 269, help them out with this one. 2 different ways at least. You can do more than that if you want to be creative. 2 different ways at least. You got really strong legs. Actually, go ahead and continue on. You don't need to stop at 69. Go all the way through. Really see how far you can get in the next 10 minutes. Work with your teams. I'm gonna try to say as little as possible unless you guys call me over. See how far you can get through the lesson in 10 minutes.
For example, the target blocker moved to the right 3 feet, 3 feet, 3 feet, and then 3 feet. It is shorter to right 4 times 3 instead of 3 plus 2 plus 3 plus 3. Note that parentheses are another way to show multiplication. Use multiplication to write 2 plus 2 plus 2 plus 2. So, I got 5 and then 2 parentheses. Okay, 2, 7, 1, 2, 7. How did Cecil detect a blocker and move it to start at point A and use his order as expression 3, 6.2 plus 2. Draw a diagram and record on finalized for finished.
Alright, real quick, just to touch base back in, because I think we're all done with this one. Oh, let's use cards still. Grant, give me a way that we can, or you just got back, never mind. Emma, give me a way that we can re-represent this. 7 times 5. Patrick, what about another one?
35 times 1.
Now, I agree, but they told us he can only move 7 feet at one time, so we can't really say that, Grant. Now, again, we could, but he can only move moves of 7. Hanukkah? Ooh, 7 times... Actually, I'd say like 3 times 7 plus 2 times 7. That's another way. Alan?
7 times 4 plus 7.
Yeah, 7 times 4 plus 7. We can break up the moves. This really, though, if I analyze and kind of do it the same way that we've done it, says 7 moves of 5. Is that really what he did? How do I rewrite that then? Instead of 7 times 5. 5 times 7. Are these the same? 7 moves of 5 and 5 moves of 7. What do we call that mathematically? That the order can change and it doesn't actually affect it. What does it mean to move? Commutative. Please jot down somewhere. Multiplication is commutative. The order is irrelevant. Whether you say he did 7 moves of 5 or 5 moves of 7, it gets us to the same place. We call that commutative. To move means to commute. Or commute means to move. So, moving on into 70. Did we get a chance to look at this? That was a very quiet response. So let's give you a few more minutes. So keep working 70, 71, 72. See how far you can get. Sorry, if you were still spelling commutative, I know some pencils were still going. Crap. That literally just bounced around the screen until it stopped moving. There. Multiplication is commutative. Commutative. So in 70, when it asks you to re-represent, I'm not trying to pick on anybody, but if our group hasn't made it into 70 yet, you're kind of working pretty slow. We want to make sure that we're keeping a good pace. Sometimes with our teams, especially if we're with our friends, we can kind of be like, adding. So you don't want to be moving in slow motion, right? Because we want to try to get through this efficiently and play the game. They re-represent 3 feet, 3 feet, 3 feet, 3 feet. That's 4 times 3 feet. 4 moves of 3. How do I re-represent 2 plus 2 plus 2 plus 2 plus 2?
5 times 2.
5 moves of 2. Which, if we appropriately match it to that, we can write like that. Or, based on commutative property, we could also say 2 times 5, and that order change doesn't make a difference. This is exactly the same as this. If there's a number right up against a parenthesis, it says sets or multiples of it. If there's a dot, it does the same thing. The only reason we use parentheses is we will get into cases where we are talking about a move, like 2 moves of a combined, like they do multiple things every time they do it. That would be when we would really want to use parentheses. Keep rolling. We will check back in. If multiplication is tough for you, break up the number. Anyone bold enough to come diagram the moves for 71? Come up and draw it out.
Is the number one count?
Yeah, like I mean, just diagram. It shows how he moved. Here, we'll get you the fancy looking pen. What color do you want? However you would diagram it. These are really open, guys. Like on the assessments, when we start to ask you, like, draw a diagram or whatever, if I don't put restrictions on there, it's pretty open to your representation, your interpretation. I want to see how you guys think it through. You realize that's a little bright. Now, are you actually going to go 6.2? Okay, I was about to say, if you do, you're going to run out of screen. Let's say I'm even working on graph paper. Do I need to show the moves as literally 6 boxes wide, like 6.2? No, we can do it. What's it called when we try to make something look right, but smaller or bigger than it actually is? Starts with an S. What would you say? No, close. Well, somewhat. Scale. Right? We want to try to implement a scale drawing. What would I say about representing or showing the 3 times 6.2? If I were drawing that, Alex? I mean, we could write not to scale if we weren't going to be to scale, but I think we're trying to do it up here. The 3 times 6.2 tells me I'm going to draw 3 moves that are the same size, right? Especially if you were being asked to do this for like a state test or something. You'd want those 3 moves that you do first to look the same size. So up on my screen, we made them just over 3 boxes wide. You want to try to do that for each of them. And then our little part on the end represents that too. So we have 6.2, 6.2, 6.2, and another 2. And we could write the values in there. Show where do we end up at? Do you know? 20.6. Questions on that one? What about 72? We'll take volunteers at the time. 72, any helpers? No. I can't tell with your face. So Cecil starts at B and walks how shown in the image. How do we write that? How do we rewrite that more so? Because I can do -3 plus -3 plus -3. Yeah.
5 times -3.
5 moves of -3. Now, if we say his start point of B was 0 in reference, where would that put him? Where would he end up? Ooh. -15. I like you to get it once I write it. Is there another way we could write this? I mean, obviously there is, since we're asking. You could also say Cecil took a move of -3 5 times, right? Now, we don't normally write it like this, but I want to show you something. This would still multiply. It's ugly. We don't like writing it like this. We normally don't. We put the 5 in front. But if there's a number against a parenthesis, it's multiplication. Please don't write it like this if you don't have to. We would put the number in front of the parenthesis because that's easier for us to think through. Patrick?
-1.5 times 10.
Oh, okay, come on. Yes. There are other ways we can write it when we change the number. It was really wanting us to use the numbers that they gave us. Sweet. So 73. Have we had a chance to look at this, or we probably need more time? Just got to it. All right, take a couple minutes. Time to make some negative groups.
Okay, so to represent 2
I love making some negative groups.
how do you
Like negative hot pockets. I
I
love your stone cold look. You're just like, look, it's not funny. I'm not really trying to be funny. I'm trying to get you guys to conceptually think about these things. Like, can I have negative groups of pencils?
Okay, 5 times -3. That. So I think.
How do we draw
5
this?
groups of negative sides.
No, no. Don't ever trust what I'm writing up here until I bring your attention back. Just things to think about.
Okay, well, if you get two groups of the three positive signs, then you get five groups, three negatives. What's that?
Groupings. So, it's really saying that this is how we can represent groups of positive values. How would we represent this expression? And you have to decide, am I going to use pluses? Am I going to use minuses? Okay, so another way to think about 73, if you were trying to show that the 5 times negative 3 using integer tiles, how would you do it? So we'll come back together in about a minute. Well, depending on who you are. You have your first middle of the day slot, is what I would say. Grant, would you like to come to the board and explain, and you can erase whatever you want or circle it, do whatever. What'd you guys do for this problem? Green's bad. Green's got the ghost.
So I think this is right, not this one.
Why? What is? Oh, so wait. Why don't you like that one?
Because, well, for thinking of it as how he made it, if there was a positive number in here, that means it goes inside the circle. So from the negative right here, there should be a negative number in the circle.
So make sure you speak up so your class can hear. But so what if? What if I'm reading this? So what Grant just said was, if I have a positive, I have put positives into the group. What if I'm reading this as a positive 5, negative 3 times? Like, what if I'm your classmate, or your sibling, or whatever, saying, but we have positive 5, negative 3 times? That is the question. How would you explain it? What does the left side of the screen show? You're in charge.
The left side of the screen.
Or you can call on somebody. I mean, like, you're like the teacher right
Yeah.
Left side of the screen shows positives.
now. What? Give me more details.
It's just positives for. It shows positive, and the next is.
So really, with how those are lumped, we're showing right, but I don't know.
Positive 5 times positive
5 3 times, right? 5 3. Can I show something negative times? How? You guys said yeah. So how do you show something positive times though? Right is closer to right, but it's not quite there. It's very close. Think about how he drew it versus, like, what am I missing? So group, show the groups. If we were to diagram this out, we need to show how these things are grouped. So I can't just show all the negatives. Like Patrick said, I can talk about what the net value is. I see the net is negative 15, but we could group this in different ways. Because it tells me I have 5 positive groups of negative 3. Grant grouped them 3 at a time. This would be wrong if I grouped them 5 at a time. Even though I get the right answer, it'd be wrong to represent the situation. Does that make sense? How we want to show the groupings? Then we'd say that equals negative 15. All right, we got 3 more minutes. let's look at 74 together. So the two expressions at the right obviously are equal. We know this. But look at A. What would 2 times 3 plus 5 mean? Alex? Yeah, so 2 moves of 3 and 5. So next week we're going to talk more, because I know I'm going to start to lose you, about what the difference between A, B, and C here would actually be. So, going to give you a couple extra minutes for your middle of the day time. That's all we'll do today. Have a wonderful weekend. It is going to be glorious outside, so please go enjoy it. If you haven't done the math homework yet, I give you permission to put it off till next week, if you're enjoying outside.
I did. Don't sit and watch Netflix videos.
Yeah, do not sit and binge Netflix. This is one of our probably last really nice weekends. Later, guys. Have fun. Have a good rest of your day. Oh, bring your parents, your family, your friends, your neighbors. Garage sale. Garage sale, garage sale.